Okay, youngins, Math 87, Lesson 97, page 595. Similar triangles and indirect measure, which are very closely related. Okay, similar triangles are triangles that are not the same size, but have the same angles. Okay, this angle and this angle are the same. This angle and this angle are the same. This angle and this angle are the same. These little tick marks, that's what tells us. The sides are different lengths. This is much bigger over here. This is bigger than this, but there's a ratio here. Okay, now corresponding angles, angle A is congruent to angle D, angle C is congruent to angle F, angle B is congruent to angle E. This is congruent with the angles, all right? So because they're similar, there's a ratio between the sides. All right, if I have, let's see, 5, 3, 6. So if we go 5, 3, 6. Let's see, 5, 3, and 6. If that's the length of these over here, and over here I have, this is 10. Now what I want to find is I want to find this side and I want to find this side, okay? So what you do is you set up a ratio. Remember ratios? On this triangle over here, I'm going to use 6 because 6 and 10 relate to each other. Okay? And then if I want to find y first, I have these two here. Do you see that? So I'm going to have 10 over x. So if I have 10 over x here, I have these two here. 6 over 5. And to find x, I just cross multiply. 10 times 5. 10 times 5 is 50, divided by 6. Ten times 5 divided by 10. 10 times 5 is 50, and 50 divided by 6. Why did I use these numbers? 3, 5, 6, 3 is the small side, 5, 10 is the hypotenuse, 6 is over there, the hypotenuse, 3 and 6. You know what? Okay. It is what it is. Usually they do examples that come out with even numbers, okay? 6 goes into 50. I don't even know. Let's see. 50 divided by 6. If I divide each by 2, I have 25 divided by 3. That's just the answer right here. Don't like that one very well, but that's what it is. All right, let's do another one over here. Let's find... Oh, that was x. I'm sorry. I'll do another one here to try to unconfuse you a little bit. So I've got that. Now I want to do y. So I'm going to go 10 over y. If I do this over this, I'm going to do this over this. Goodness, Alan. 6 over 3. 10 times 3. This is a y, not a 4. 10 times 3 is 30. Divided by 6 equals 5. So this side over here is 5. Okay? Does that kind of make a little bit of sense what we're doing there? I really wish they hadn't done that one triangle there because that was kind of an oddball kind of thing. Let's see, 6, 10. Let's try a different one over here. With just different numbers, okay? That's all I'm going to do is change the numbers. The work remains the same, okay? The triangles are still similar. But let's try this one. On the little one, we'll have 10 on the big side, 6 and x over here. And on the other triangle, we'll have 15 on the big side. And then 12. So between the 1 and 6. 6 is between there So I'm going to have y here, and I can't even see 12. 12 here, all right? I think I have this set up the way the book has it set up. This is just a different one. So if I want to find x, see, what I want to do is I want to find the ones that are have a relationship with each other. These two and these two have the relationship. So if I go, say, x over 10, then I do 12 over 15. Okay, and then you do cross multiplication. 10 times 12 is 120, divided by 15. I can't even think in my head here. 15 goes in 100. I can't even think. I'm sorry. 120 divided by 15 is 8. So this is 8. Right here. This is 8. Okay? So you set up another ratio over here. I'm sorry, my division is great. So I want y this time, so I'm going to take these two, 15 and y, and 10 over 6 here. Again, this is not a 4, that's a y. All right, so I want 15 times 6, 15 times 6 divided by 10. So 15 times 6, that's 30, 6, 7, 8, 9, and I take 90 and divide it by 10, that is 9. Okay? See how that works? You want to set up a ratio. So you're going to take one that you're looking for, one that you have. On the other triangle, they have to be two that you do have. I can't use these two to find these two. You understand? All right? So similar triangles. Now, indirect measure is like this. If we're outside, maybe we do this someday if we ever come back to school, and there is a tree over here, okay? Here's a tree, and it's on the ground, and it casts a shadow, okay? The sun is up here shining brightly, so it casts a shadow over here like this, okay? So here's the center of the tree. This is called a right triangle right here. All right, now over here, I put a stick in the ground that is, say, 1 meter tall. And the same sun is shining on this 1 meter stick, and it's going to cast a shadow. Okay, these are similar triangles. This angle and this angle, or wherever I'm at, this angle here are the same. And this angle are the same, and these two angles are the same. Therefore, the relationship of the sides is the same. So if I have my 1 meter tall stick, let's come back over here, and let's just say the 1 meter tall stick casts a shadow that is 4 meters long because I measured it. Okay, and what I can do is I know how to measure. I can measure this pretty easy. A little bit hard to crawl up on top of the tree with a stick. I want to find out how tall the tree is. I want to find out what this is on this triangle. Okay, so I set up a ratio. I have 1 over 4, and on the tree, I have I have 24 over here. Okay? So what I have is something that looks like this. And I'm looking for how tall the tree is. Okay? This is the height of the meter stick. This is the length of the shadow. So this is the height, and this is the length of the shadow. This is the height that I don't know. This is the length of the tree. So it's this times this divided by this is this. 24 divided by 4 is probably right around the 6. Okay, so what that's telling me is if it casts a 24-meter shadow, then it's 6 feet tall. Okay? If I'm doing this, or meters if you want. Let's do meters. So if my 1 meter stick is cast in a 4 meter shadow, then my shadow over here is 24 meters. The height of my tree is 6. It's called indirect measure. Indirect measure. Okay? Blah, 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 blah. Let's see. I think that's it. Okay.